Now here's a triangle in a coordinate plane, A, B, C. I wrote the coordinates of the original vertices. Vertex A is negative 10, 8. Vertex B is 5, 8. And vertex C is 5, negative 7. I wanted you to rotate the triangle 90 degrees counterclockwise. And remember, counterclockwise means you're going left. So this whole triangle needs to go left only 90 degrees. So let's see how this works. Here's the triangle. This is the original triangle. I wanted you to rotate this 90 degrees counterclockwise, which means you are going left this way. And it's 90 degrees about the origin, and that's how the triangle would look like, or the image after the rotation would look like. So let's see, applying this simple rule that we talked about. 90 degrees and 270, switch X and Y, and the signs depend on the quadrant. How does that work? Every vertex, A is negative 10, 8, switch X and Y, it becomes 8 and 10. Do not write the signs, we'll worry about it later. B, 5, 8, switch to 8, 5. In C prime, it was 5, negative 7, switch, it'll be 7 and 5. Now let's talk about the signs depend on the quadrant. A 90-degree counterclockwise will land in the third quadrant where X is negative, Y is negative, so they're both going to be negative. Let's think about B. B is in the first quadrant. 90 degree, it's going to land in the second quadrant where X is negative and Y is positive. C, when it turns counterclockwise 90 degrees, it's going to land in the first quadrant where both positive, so I'm going to keep them the same. So let's see if that works. A prime is negative 8, negative 10 is negative 8. So walk to negative 8 to go down to negative 10, put the dot and name it A prime. B prime is negative 8, 5. So walk, start from the origin, walk to negative 8, go up to 5, put the dot and name it B prime. Now C prime is 7, 5. So walk to the 7 on the x-axis and go up to 5, and that would be your C prime. Now connect them. And that's the image. Since the corresponding angles and corresponding sides are the same, then triangle ABC is congruent to triangle ABC prime because it is a rotation, and rotation proves congruency. That's how you rotate, just by remembering. If you're going to 70 or 90, switch X and Y, and think about where would it land in which quadrant. That's how you decide what the signs are. Okay, now here's another triangle, ABC. It's a smaller triangle, and we need to rotate the triangle 180 degrees. Do I need to say clockwise or counterclockwise? No, because it doesn't matter if you go clockwise or counterclockwise, 180 degree, you will land the same place. Remember the rule of rotation, change the sign of X and Y, and then plot them. Don't switch anything, just change the signs. So A is 0, negative 5. A is 0, negative 5. So all you have to do, change the sign. The 0 does not have a sign, so stays 0. And the negative 5 becomes positive 5, and that's the A prime. B prime, change the positive to negative, so it becomes negative 3, and the negative to positive becomes positive 2. And C prime, change the signs, both of them will become positive 4 and positive 2. Now plot them. I am going to use a different color so you can see it. A prime is 0, 5, so do not walk anywhere, just go up to 5, put a dot, and name it A prime. Now B prime is negative 3, 2, walk to negative 3, then jump up to 2, and that would be B prime. C prime is 4, 2, walk to 4, go up to 2, and that's C prime. Now connect them. And that's a rotation 180 degrees. I know this is for sure 180 degree rotation by checking if the vertex C and C prime made 180 degree. And it did. I don't want to draw all the lines, but B with B prime made 180 degrees and A prime with A made 180 degrees. I know for sure it's a rotation. Some of you will say this is a flip. It's not really a flip. It's not a reflection because the orientation have changed. If you imagine taking this triangle, 90 degree would go up this way and 180 another way. So the C is on the opposite direction. Flip, it would be the C is on the same way, B is on the same way, and the distance would be the same, but it's not. So I know it's not a reflection. This is a rotation, and it works. Now I need you to translate the image, x plus 2, y plus 2. The image, and the image is the blue one, where A prime is 0, 5, and B prime is negative 3, 2, and C prime is 4, 2. Since x is increasing by 2 and y is increasing by 2, you can count spaces from here. The whole triangle needs to go to the right 2 and up 2. It's going to end up right here. Or you can apply the rule that is x plus 2, so 0 plus 2, and 5, which is the y plus 2. And you end up with a double prime of 2 and 7. B is negative 3, 2, so negative 3 plus 2, and 2 plus 2. You end up with negative 1 and 4. C prime is 4, and now I need to add 2 to it. And the y, which is 2, I need to add 2 to it. 4 plus 2 is 6, and 2 plus 2 is 4, and those are the coordinates of the double image. Now plot them. Let me see if I can find another color to do that. A double prime is 2, 7. Here's 2 and 7. And this is A double prime. B is negative 1, 4. Here's negative 1. And here's 4. And that's B double prime. C is 6, 4. So walk to 6 up to 4. And that's C double prime. Plot them. And you end up with a translation to the right 2, up 2, each vertex translated to the right and up. Triangle ABC is congruent to triangle ABC prime because it's a rotation of 180 degrees. And triangle ABC prime is congruent to triangle ABC double prime. Why? Because it is a translation. That's it for today's lesson. Hopefully it made sense.